Today, we'll be discussing the crucial role of artificial intelligence services, specifically natural language processing and computer vision, within the cloud computing landscape. This presentation is part of our INFO36 cloud computing project. My name is Javonte Baldeo, and I'm presenting on behalf of my group members, Akiba Silvan and Teal Trim. We live in an era dominated by data. Much of it is unstructured. Harnessing this data is key, and that's where AI services like natural language processing and computer vision come in. Major cloud platforms like Amazon Web Services, Google Cloud Platform, and Microsoft Azure are making these powerful AI capabilities accessible, scalable, and cost-effective. These platforms allow organizations to gain insights, automate workflows, and innovate rapidly, even without in-house machine learning experts. Today we'll cover the technology landscape, dive into specific use cases, explore integration strategies, discuss security and compliance, analyze costs, assess scalability and flexibility, and finally conclude.
Technology landscape analysis. Natural language processing applications are mainly used today for different reasons. Some of these reasons are for sentiment analysis, entity recognition, language translation for multilingual support, social media, and chatbots. Some computer vision applications are object recognition, video processing for inventory management, OCR for invoice or medical record processing. Some benefits of these are lower operational costs, timely decision making, elastic scalability, pay-as-you-go pricing, rapid deployment, and continuous model updates. Some strategic considerations to note: focus on high-impact use cases, cross-functional teams, upskilling, ethical considerations, and bias regulations. Some key use cases of AI services and how it can better enhance today's technologies are customer service enhancement. Natural language processing models can help enhance customer service experience by providing virtual assistants or chatbots for real-time, accurate responses. This was done by AT&T, a well-known mobile company, which has seen a 20% efficiency gain in its usage. Another use case for AI services are retail applications for automated checkout, inventory management, theft detection. Another use case for AI services is intelligent document processing. With this, automation, extraction, classification, and validation from documents are extracted with the use of AI. This has been seen to speed up workflows by 50% in insurance, healthcare, and many government jobs.
Integrating multiple AI services requires thoughtful strategy but yields powerful results. Imagine combining a natural language processing computer service bot with an automated reasoning system to ensure responses are not only timely but also compliant with regulations. A multi-layered approach works best. At the data layer, robust governance and centralized data lakes or warehouses, like those from Snowflake or AWS, ensure data quality and availability for AI. At the application layer, using AIs and a microservices architecture promotes modularity. Platforms like IBM Watson or Microsoft Azure provide tools to manage and orchestrate these services within existing applications, enhancing scalability. At the user experience layer, unified interfaces allow users to seamlessly interact with the combined AI capabilities, driving adoption. This holistic strategy maximizes the return on AI investment. Adopting cloud AI services necessitates a strong focus on security and compliance. Key goals include data protection, regulatory adherence, and building user trust. Data privacy is paramount, especially when cloud providers process sensitive information like PII or customer communications. We must mitigate unauthorized access through techniques like data anonymization and strict access controls. Cloud providers offer tools for this. AWS provides KMS for encryption and IAM for access control. Google Cloud offers Cloud KMS and IAM. And Azure provides Key Vault and Active Directory. Data integrity throughout the AI pipeline is crucial to prevent inaccurate outputs. This involves secure data transfer using HTTPS/TLS, audit trails, and validation. Robust identity and access management (IAM), following the principle of least privilege and using multi-factor authentication, prevents unauthorized access to models and data. While providers secure the infrastructure, enterprises must secure the AI models themselves against attacks. Using techniques like input validation, secure network communication using VPNs or private links, along with firewalls and monitoring via tools like AWS VPC or Azure Virtual Network is also essential. Compliance with regulations is non-negotiable. If you process personal data of residents using NLP or CV, perhaps analyzing customer feedback or using facial recognition, you must comply with GDPR. This involves ensuring a lawful basis for processing, minimizing data collection, respecting data subject rights, and managing data transfers correctly. For healthcare organizations, processing protected health information with AI, like analyzing clinical notes or medical images, HIPAA compliance is mandatory. This requires business associate agreements with cloud providers and specific technical administration controls, like encryption and audit logs. Similarly, processing payment card information requires adherence to the PCI DSS standard, involving controls around the network security, data protection, and access management. Let's summarize the key risks and how to mitigate them. For data breaches or unauthorized access, the strategy involves strong IAM end-to-end encryption, robust network security, and regular audits. To avoid compliance violations, conduct thorough legal reviews, establish clear data governance, choose certified providers, and implement necessary technical and administrative safeguards. You must address data integrity issues with secure transfer methods, audit trails, validation processes, and monitoring. Counter AI model security vulnerabilities by following best practices and implementing input validation. And finally, manage data residency issues by selecting appropriate cloud regions and using provider tools to control data location.
Hello, my name is Tiltram, and I will be covering cost analysis and scalability and flexibility assessment. So let's start with cost analysis. When you want to implement cloud-based AI services like computer vision and natural language processing services, especially if you want to host them with big name services like AWS, Google Cloud, or Azure, you're going to need an understanding of their usage-based pricing models. So costs are typically calculated per API call, or per character, or per image, or per document. As your needs scale up, obviously these costs can balloon. And you'll need techniques like batching requests, caching outputs, or using cheaper off-the-shelf pre-trained models, at least when you're handling simpler tasks, to help control costs. Additional strategies include things like serverless processing, spot instances, and automated storage management. These can further help reduce your expenses. When it comes to scalability and flexibility, cloud-based computer vision and natural language processing, at least with the big name services like, again, AWS, Google Cloud, and Azure, they offer built-in features to help with your scalability and flexibility. They have things like cloud-native architectures, global infrastructures, so you can deploy closer to your customers to minimize latency, and they have dynamic pricing models to help you control your costs. They all have their own unique features. AWS has really great serverless options. Google Cloud it's really good at data-heavy operations, and Azure integrates really well with all the tools in the Microsoft suite. Of course, you still want to be careful about vendor lock-in. To conclude, Cloud-based natural language processing and computer vision offers a ton of advantages for extracting insights from what used to be unstructured data. However, it's crucial to align these technologies with broader organizational strategies and to adopt AI responsibly. You need to select providers that best match with your business's specific needs. And if you do all this right, you can end up with scalable, efficient, and highly customizable AI deployments that massively improve your operations. This concludes our presentation.